Our next chapter is about functions in C++, how to declare and how to use these functions. So function a function is a name block of code that performs some action. The statements written in a function are executed when it is called by its name. Each function has a unique name. Function are the building blocks of C++ program. They encapsulate pieces of code to perform specific operations. The functions are used to accomplish the similar kind of tasks again and again without writing the same code again. They are used to perform the tasks that are repeated many times. The control moves in the function when a function is called. All statements of the function are executed and then the control again moves back to the point where the function was called along with possible return value. The functions provide a structured programming approach. It is modular way of writing programs. The whole program logic is divided into a number of smaller modules of functions. The main function calls these functions when they are needed to execute. So far, we have experienced functions in two ways. We have created a function named main, or we used int main in every program you have written. And we have used library functions such as power when we want to find the power of a number, or we want to find the square root of a number. We used a built-in function which are called library functions. In this chapter we will learn how to create your own functions that can be used like library functions. Divide and conquer. Functions are commonly used to break a problem down into small manageable pieces. Instead of writing one long function that contains all of the statements necessary to solve a problem, several small functions that each solve a specific part of the problem can be written. These small functions can then be executed in the desired order to solve the problem. This approach is sometimes called divide and conquer because a large problem is divided into several small problems that are easily solved. The program may need to repeat the same piece of code at various places. It may be required to perform certain tasks repeatedly. The program may become very large if functions are not used. The piece of code that is executed repeatedly is stored in a separate function. The real reason of using function is to divide a program into different parts that these parts of a program can be managed easily. This figure illustrates this idea by comparing two programs. One that uses a long complex function containing all of the statements necessary to solve a problem on the left hand side, and on the right hand side and other program that divides a problem into smaller problems, each of which are handled by a separate function. Another reason to write function is that they simplify programs. If a specific task is performed in several places in a program, A function can be written once to perform that task and then be executed anytime it is needed. This benefit of using functions is known as code reuse because you are writing the code to perform a task once and then reusing it each time you need to perform the task. So function is a logically grouped set of statements that perform a specific task. For example, a function with the name sort may sort a group of data. And similarly, every C++ program has a function named main where the execution of the program starts. It is a mandatory function in C++. Functions are used for divide a large code into module. Due to this, we can easily debug and maintain the code. For example, if we write a calculator program at that time, we can write every logic in a separate function for addition, sum, for subtraction. Any function can be called any time. Imagine you are making a game and you need to display the score. Frequently, one solution is to write the whole code to display the score again and again whenever wanted, but there is another better solution using function. Define that whole code is a function and call it whenever you want. A function is nothing but a group of codes written together and give a name, and these can be called anytime in the main function without typing the whole code. So functions are easier to maintain than long programs. Each function contains independent code. A change in the function does not affect other part of code. The code written in function can be reused as and when required. A function but can be executed many times. A function is written to solve a particular programmer problem. Whenever that problem has to be solved, the function can be executed. Program may consist of many functions. These functions are written as independent programs. Different programmers can work on different functions at the same time. It takes far less time to complete the program. These are some advantages of the functions. Function number one, functions separate the concept what is done from the implementation how it is done. Number two, function made program easier to understand because each a lengthy program can be divided into small functions. It is easier to write small functions instead of writing one large program. A function is written to solve a particular problem. A programmer can focus attention on a specific problem. It makes programming easier. So functions make programs easier to understand. Function can be called several times in the same program, allowing the code to be reused. Function avoid repeating of code again and again. Function develop an application in modular format. Functions are easily to debug the program. Functions are easier to maintain than long programs. Each function contains independent code. A change in the function does not affect other parts of the program. Code optimization, no need to write lot of codes, divide a complex problem into many similar problems, make unit testing possible. So these are the some sorry advantages of functions. Library functions are those which are predefined in C++ compiler. Built-in functions are also called library functions. These are the functions that are provided by C++ and we need not write them ourselves. We can directly use these functions in our code. These functions are placed in the header files of C++, for example, CMath or string header files are the header files that have in built math functions and string functions respectively. So if we use CMath header file, then we are able to use sine, cosine, clear, power, square root, built-in functions in our programming. Example of library functions or built-in function is as int main, double number, square root. We declare two variables with a number and square root with the data type double. Then we want user to enter the value of the number. Then we use our built-in function, our library function square root to calculate square root, such as uh, square root into number, and the result is goes to our declared variable square root. Then we display the value of the square root of that number, and then the program is end. For example, if user enter a program 25, then the output of this number 25 is equal to 5. Let's of this program. In this program, square root library function is invoked to calculate the square root of a number. Notice that code includes CMath in the previous program. Here CMath is a header file. The function definition of square root body of the function is present in the CMath header file. We can use all functions defined in CMath when you include the content of file CMath in this program using include CMath. Every valid C++ program has at least one function that is main function. So limitation of library functions is as all predefined functions are contain limited task only that is for what purpose function is designed for same purpose if it should be used. As a programmer, we do not having any control on predefined functions. Implementation part is there in machine readable format. In implementation, where whenever a predefined function is not supported, user requirement then goes for user defined functions. So user defined function C++ also allows its user to define their own functions. These are the user defined functions. We can define the function anywhere in the program and then call these functions from any part of the code. Just like variables, it should be declared before using. Functions also need to be declared before they are called. For example, You want to create a function for adding two numbers, then you create a function with the name sum. This type of function is called user defined function. Components of function. A function usually has three components. These components are function prototype or declaration, function definition, and function call. Function prototype. Like variables, all the function must be declared. Function declaration statement includes function name, what function will take, and what function will return. The syntax of function prototype is such as return time, then we write the function name, and then into the parentheses we write the argument lists or the variables. So when creating a function, you must write its definition. All function definitions has the following part. First one is the return type. A function can send a value to the part of the program that executed it. The return type is the data type of the value that is sent from the function. So this return type may be an int, float, char, string, and if there is no return type, then we use a keyword void. So second part is the name, function name part. You should give each function a descriptive name. In general, the same rule that apply to variable names also apply to function names. Number three is the parameter list or argument list. The program can send data into a function. The parameter list is a list of variables that hold the values being passed to the function. And another part of a function is the body of the function. The body of a function is the set of statements that perform the function operations. They are enclosed in a set of braces. So again, the example of declaration of a function, if we want to return the sum of two integers numbers and function will take two numbers as argument, then the function declaration statement will be int add and into parentheses number one and number two. So in this function we have two variables with name int number one and number two, and both variables has a data type of integer data type. We name this function add, and after solving the problem, this function returns us a value, and that value is an integer type. So we use the return type as int. Example of declaration of a function. Here are some examples how to declare a function. If we not use any data type, then we use keyword void in the place of return type. So void display, and display is the name of the function, and into the parentheses we write the char and mean any character that we want to display. So here function name is equal to display receives a character as argument and returns nothing. Similarly, we have another function declare which is int sum int. This function with the name sum receives two integers as argument and return an integer, which means this function sum two numbers and return main program. So first thing is what is a return value type. Function may or may not return a value. So if a function return a value, we use that values data type, and if function not return a value, then we used void keyword. So return type may be int, float, char, or any other valid data type we used in C++. The keyword is if we use int, float, char, or any other valid data type, then we used a keyword return to return some value from the function. The data type of the returning variable should match with return value data type. If the function does not return any value, then keyword void must be used. So second part is the function name. Function name should be self-explanatory. Same rules for variable naming conventions are applied to the function names. For example, scale raised to the power, country name, etc. Uh, so the function name must be a unique. The syntax of the function definition is as return type function name and the argument list, and then into the curly braces we write the body of the function. Here is an example of definition of function. The body of function for calculating sum of two integer numbers must be look like as first we define the function with int add int number 1 and int number 2. Then we write the body of this function. Into the body of this function we use number 1 and number 2. We add them and place their sum into another variable, and we name that variable sum. So this result will be returned to the main program which call this program. So we use return sum. It consists of the declaration and statements. The task of the function is performed in the body of the function. This is the body of the function where we declare a variable sum. Then we use this variable to sum number 1 and number 2 variables. And then we return this sum back to the program. Function can return values. A return statement is used to return values to the invoking functions. The type of value a function can return is specified in the function prototype. A function which has void as return type do not return any value beside basic data type. It can return object and pointers too. A return statement is usually placed at the end of a function definition or inside a branching state. In this function, the return type of sum is int. So it returns an integer values to the invoking function. So here is the basic for the function definitions. A function has the following parts: return type, function name, parameters list, and function body. So again, return type. Return type is the type of data that function returns. It is not necessary that function will always return a value. Function name is the actual name of the function name and the parameters list together forms the signature of the function. Parameter list allows passing argument to the function from the location where it is called from. Parameter list is separated by commas. Function body. The function body contains a collection of statements that define what the function does. Function call or function invoke. The third part of calling a function. To execute function, we must call it. A function can be called or invoked by using function name followed by list of argument that function definition will receive to perform task. So the syntax for calling a function is look like as function name, and then into the parentheses we write the parameter list or the actual list. These parameter are argument are passed to the function which use these arguments or parameters to perform the specific task on them. So while writing our code, sometimes we use this syntax, the following syntax for calling the function, which is as any variable var is equal to function name and into the parentheses the parameter list. Here var can be any variable that will receive value returning from function definition. For example, we write a, b, or some or any other name is equal to function name and actual arguments. So here are the examples for function calling. To call a function, we simply write the name of the function and we pass arguments into parentheses. So here display into a displays the name of the function and a is the parameter list. We also write function s is equal to sum in num1, num2. Here s is the variable which store the result of the function sum and its variables num1 and num2. Similarly, we also write a function call as result is equal to addition 5 and 3 instead of writing number 1, number 2, or instead of writing a comma b comma c comma d, we write direct values into the parameter list. In calling programs, write the name of the function and provide its arguments without data types. In calling a function, return value type and data type of the arguments are not written. So these are the arguments. In this example, we write a function void sum int number 1, int number 2, then we add these int number 1 and number 2 and store their result into a result variable. And in our main program we call this program as sum number 1 and number 2. So you may clearly see that when we call this function, we did not use the data type of the arguments. Mean when we call this sum function, we write sum, and you clearly see that we have no return type, any return type. And into the parentheses, we did not write int, float, char. We directly write the variable names, or we directly write the values into this function. So these number one, when we write sum num1 comma num2, then when compiler goes compile this line, the control goes to the void sum int number one, and number one contains the same value which we used in calling the function, comma int number two, and in number two, now here number two use the same value which is defined in uh, program calling variable number two. So so upper is the function definition and lower is the function calling, and these are called the formal parameters, actual parameters. So the sequence and types of parameters in function call must be similar to the sequence and types of parameter in function declaration. The parameters in function call are called actual parameters, and parameters in function declaration are called formal parameters. When a function call is executed, the value of actual parameters are copied to the formal parameters. So the numbers of actual arguments are parameters and formal arguments are parameters should be same. The type of first actual parameter should match the type of first formal parameter. Similarly, type of second actual parameter should match the type of second formal parameter, and so on. We may call function without passing any arguments. The numbers of argument or parameters passes to a function depends on how programmer want to solve the problem. Let's have the example in this program. First of all, after writing include iostream, we write using namespace std, then we define our function int addition int a int b, then we write our main program. So before writing our main program, we declare our function. In our program, we declare a variable z, and we use this variable z as z is equal to addition 5 into 3. Uh, we want to add 5 and 3 and want to store the result into z. So instead of writing z is equal to 5 plus 3, we use a function addition. This function adds 5 and 3 and store the result into z. Then we use cout to display the sum of 5 and 3. So after that, so our int main program is completed. Now we write our function which perform addition on 5 and 3. So we want as we want to return this function a value into the variable z, so we use uh, return type int, and then we write the function name addition, and then we use two variables, formal variables, and int a, int b, because we want to add 5 and 3. 5 is an integer value and 3 is an integer value, so we use int a and int b. So instead of writing int 5 int 3, we similarly use two variables, int a and int b. A contains the value 5 and b contains the value 3, and then we write the body of the function. In the body of the function we declare another variable r, and then we write r is equal to a plus b, and then we return this value stored in r back to the uh, main program, where we write z is equal to addition 5 plus 3. So this is our function declaration, int addition, int a, int b. This is our function body. Uh, our function call. Here we call the function, and when we call the function, then control goes to int addition, int a, int b, and this, and into the body of this function we perform the addition of 5 plus 3, and the result is 8. In this example, main begins by declaring the variable z of type int, and right after that it performs the first function call. It calls addition. The call to a function follows a structure very similar to its declaration. In the example above, the call to addition can be compared to its definition just as few lines earlier. So here is the example: int addition, int a, int b, z is equal to addition, 5 goes to a and 3 goes to b. The parameters in the function declaration have a clear corresponding to the parameters passed in the function call. The call passes two values 5 and 3. These 5 and 3 call the actual parameters to the function. These correspond to the parameters a and b, where a and b are called the formal parameters declared for function addition. This function is called from within the main function. The control is passes to the function addition. Here execution of main is stopped, and will only resume once the addition function ends. At the moment of the function call, the value of both arguments 5 and 3 are copied to the local variables int a and int b within the function. Then inside addition, another local variable is declared int r, and by mean of the expression r is equal to a plus b, the result of a plus b is assigned to r, which for this case, where a is 5 and b is 3, means that 8 is assigned to r. The final statement within the function return r. Ends function addition and returns the control back to the point where the function was called. In this case, two function main. At this price moment, the program resumes its course on main, returning exactly at the same point at which it was interrupted by the call to addition. But additionally, Because addition has a return type, the control goes back to the main program, and this value in the value specified in the return statement that ended addition. In this particular case, the value of the local variable r, which at the moment of the return statement had a value of r. Therefore, the call to addition is an expression with the value returned by the function, and in this case that value 8 is assigned to z. It is as if the entire function call addition 5 plus 3 was replaced by the value it returns, which is 8. Let's have another programming example. In this example, we want to print stars on the screen. So first of all, we declare our function, and as this function only prints the stars on the screen, so it did not need any return type. So we use void print stars, and we need no arguments because we only want to print the stars on the screen. Then we write our main program. Into our main program, first of all, we out C, we write a dashes line above the stars. Then we call our function print stars. So similarly, after calling the function in the main program, we write another line, and then we end the main program. When this program executes, compiler reads cout and it prints a dashes line on the screen. Then compiler reads print star and wide parenthesis. Now the control goes to the function. Here goes to the function where we write our print star function. So control jumps from print star to the wide print star and into the body. We use a for loop to print stars up to 15 times. So after printing all the stars, the control goes back to the main program, and the next cout display another dashes line below the stars, and then our program terminates. Let's have another problem statement. Write a C++ program using function which accept two integers and argument and return its sum. Call this function from main and print the result in main. In this problem, we want to add two variables, and we want to display the result of these two variables within the main function. So of our problem, first of all, we want to add two variables, so we declare a function. We name it as a function sum, int sum, and as it used two variables, so we declare two variables here, int comma int. Then we start our main program. Into our main program, we use two variables, number 1 and number 2, and we use another variable s to store their sum. Then we ask user to enter first number, and then we ask user to enter second number. Then we use s to sum these two numbers, and we use a function sum to perform the addition of these two numbers. So we write s is equal to sum. Sum is the function sum into num1 and num2. So this function So here is the call of our function. Then we want to display the sum of number 1 and number 2 into the main program. So we write cout the sum is, and we display the sum of our two variables here. And then we end our main program and write the our user look like as int sum, and then int number 1, int number 2. Then into the body of this function we use another variable total, and we use this variable total to sum number 1 and number 2. Then we return the value stored in back to the main program. So the output of this program should be look like this. Enter first number, user may enter 3, enter second number, user may enter 5, and the sum, then it display on the screen the sum is. So in this problem statement we want to write a function which calculates the raised to power of a input base number up to given power number. So first of all we declare our function and we name it raised to power. So if we want to calculate the power of any number, then we use two variables, int base and int power. Then we write the body of the program. In the body of the raised to power function, we declare double result is equal to 1.0. For int I is equal to 1, I less than power, I plus plus, and we use for loop to find the power. Result multiply is equal to base, mean result is equal to result multiplied by base, and then we return this value back to the main program. To our main program we declare two variables, base and power, and we declare another variable which store its their result, and we name this variable result, and its data type is double. So we asked first of all in the main program we write cout enter base, means we want user to enter desired base number. Then we ask user to enter the number power of the base. Then we call our raised to power function to calculate the power of that base number, and then we display the result of our function. So for example, if user write base 2 and then want the power of 2 to the power 5, and he write base 2 and power 5, then result will be 32. 2 to the power 5 is equal to 32. Problem statement 3. In this problem statement, write a C++ program to show prime numbers between two intervals by making user-defined function. Mean between any two intervals we want to show the prime numbers. Here is the solution of our problem. First of all, we declare our function int check prime and int num. Then into the main program we declare the function variables n1, n2, I and flag. Then we ask user to enter two numbers intervals, and user enters two number interval 1 and 2. Then we display the prime numbers between n1 and n2, and for displaying the prime numbers we used for loop for I is equal to n1 plus 1, I less than n2 plus I. Then we write the body of the for loop. For is equal to check prime. Into the body of the for loop we call our function named check prime and with an argument I. Then we check the condition. If flag is equal to 0, cout I is equal to NL, means if it is a prime number, then it displays the number on the screen. Otherwise, it shows nothing. Here is our check prime function. Into our check prime function, in the body of check prime function, we declare function int j flag 0, flag is equal to 0, for j is equal to 2, j less than num divided by 2 plus j. If num modulus j is equal to 0, then flag is equal to 1, and then we use break, and again for loop begins. At the end, the result in the flag returns to the main program. So after running this program, it asks user to enter two numbers. These two numbers are used for number interval. For example, user enter 1 and 10. So this program now calculate prime numbers between 1 and 10. Then our program calls the check prime function, and check prime functions runs through 1 to 10 times, and it finds the prime numbers and it display on the screen, which are 2, 3, 5 and 7. In our switch case lecture, uh, we write a calculator program. So here is your task, that write a program that lets the user perform arithmetic operations on two numbers. Your program must be menu driven, allow the user to select the operation plus, minus, multiply or divide, and inputs the numbers. Furthermore, your program must consist of the following functions. First function shows choice. This function shows the option to the user and explain how to enter data. Second function is used to add the values. This function accepts two numbers as argument and returns their sum. Third function is subtract. This function accepts two numbers as argument and return their difference. Third function for multiplication, this function accepts two numbers as argument and return product. Fifth function is divide. This function accepts two numbers as argument and return their quotient. So what you do when programming this program? Simply use our switch case program where we design a calculator, and instead of every case where we use case to calculate the addition, subtraction, multiplication and division, similarly instead of case define functions there for addition, subtraction, multiplication and division, and then call these function into the main program.